Good morning to all. Today we are discussing about TTL NAND gate with the totem pole output structure. Okay. Introduction. In the last class we studied about TTL NAND gate with passive pull-up network. This is the circuit diagram of the passive pull-up network. Okay. In this circuit we are giving the both the inputs are 0 0. At the time the emitter B junctions of the diodes are in forward biased and the collector B junction diode is reverse biased. Therefore, the Q1 transistor is operate in the active region. Clear? And the output of this Q1 transistor is logic 0. That output is given to input of this Q2 transistor. Okay. The sufficient voltage is not given to the input of this Q2 transistor and the Q2 transistor is operate in the cutoff region. Clear? And the output of this Q2 transistor is given to input of this Q3 transistor. When this Q2 transistor is off, we are get the output is logic 0. That output logic 0 is given to input of this Q3 transistor and the Q3 transistor is operate in the cutoff region. Clear? At the time, the conducting path existing from VCC to output terminal V0. Okay. So, in this circuit, we are connecting one capacitor at the output side. So, when the conducting path exists from the VCC to V0 and the capacitor start to charging. Okay. So, the charging time constant of this circuit is more. The charging time constant is increased, then the propagation delay of the circuit also increases. Now we are minimizing the propagation delay of this TTL family at the collector resistor RC3 is replaced with another transistor Q3. So that combination we are called as totem pole output structure. Okay. That is, the idea of variable RC is accommodated by TTL IC. It uses another transistor Q3 in place of RC to act like varying resistance. It means that in this circuit we are replacing this collector resistor RC3 by another transistor Q3. That combination of this Q3 and another transistor we are called as totem pole output structure. Okay. Two input TTL NAND gate using totem pole output as shown in figure. Okay, this is the two input TTL NAND gate using totem pole output circuit diagram. This circuit diagram consisting of three stages. Okay, this is input stage and this is we are considered the phase splitter stage and this is we are considered the output stage. Okay, coming to the input stage, have the Q1 transistor. The Q1 transistor have multiple emitter terminals. Based on this emitter terminals, we are mention the number of inputs of TTL NAND gate. Okay, and the Q1 transistor output is given to the input of this Q2 transistor. Here, the Q2 transistor is acting as switch and this Q2 transistor is acting as a phase splitter. It means that this Q2 transistor is operate the another two transistors, that is Q3 and Q4. For example, this Q2 transistor is off. Okay, at that time the output of this Q2 transistor, that is logic 1 is given to the base terminal of this Q3 transistor and logic 0 is given to the base terminal of the Q4 transistor. Okay, and for example this Q2 transistor is on. At that time the logic 0 is given to the base terminal of this Q3 transistor and logic 1 is given to the base terminal of this Q4 transistor. So based on this switching action, we are consider the inputs of these two transistors Q3 and Q4. Okay, and coming to the output stage. Okay, this output stage consisting of this R3 and this transistor Q3 and the diode D and Q4 transistor. So this combination we are called as totem pole output stage. Okay, so with the help of this totem pole output circuit, we are minimizing the propagation delay of the TTL circuit. Okay, and in this circuit we are using the diode for ensuring the which transistor is on and which transistor is off. Okay, that is Q3 and Q4 transistors. Okay, and next we are discussing the operation of this two input TTL NAND gate using totem pole circuit. Okay, here we are mentioning the two input sides, therefore we got the four possible combination. The first possible combination is both the inputs are 0 0. That is, when both the inputs are logic 0, the emitter junctions of the transistor Q1 are forward biased. So transistors Q2 and Q4 are in cutoff and the transistor Q3 in saturation. The output voltage is equal to the supply voltage VCC. That is, we are considered the output is in logic 1 state. It means that in this circuit we are giving the both the inputs are 0 0. As per our understanding point of view, here we are draw the equivalent circuit of this Q1 transistor. Okay, so here we have the two diodes. Okay, these two diodes they are considered the emitter B junction diodes, and this is we are considered the collector B junction diode. When we are giving the both the inputs are 0 0 and these two diodes are operate in the forward bias condition. Okay, therefore here we are getting the logic 0 and this collector B junction diode is in reverse bias flow. Therefore, the Q1 transistor is operate in the active region. Okay, and we got the output of this Q1 transistor is logic 0. Clear? And this output is given to the input of this Q2 transistor, and the sufficient voltage is not given to the base terminal of this Q2 transistor, and the Q2 transistor is operate in cutoff region. Therefore, this Q2 transistor is off. Okay, at that time here we got the logic 1 from the VCC, and here we are considering the logic 0 the input of this Q4 transistor. So when we are got the logic 1 for the input of this Q3 transistor, the sufficient voltage is given to this base terminal of this Q3 transistor, and the Q3 transistor is operate in the saturation region. Okay, so this Q3 transistor is acting as closure switch. Okay, and when we are applying the logic 0 is input of this Q4 transistor, the sufficient voltage is not given to the base terminal of this Q4 transistor, and this Q4 transistor is operate in the cutoff region, and this Q4 transistor is acting as open switch. Okay, so with respect to this Q3 transistor, in the circuit, there exists a conducting path from VCC to output. Therefore, we got the logic 1 is output. Okay, and the next possible combination of input is when any one of the input is at logic 0 level, the corresponding emitter junction of Q1 is forward biased and Q2 and Q4 are in cutoff and the transistor Q3 in saturation. The output voltage is equal to the supply voltage VCC. That is, we are considered output is in logic 1 state. It means that in this circuit, we are considered any one of the input is high and other input is 0. Okay, so here we are considered A input is logic 1 and the B input is logic 0. Clear? So those inputs are high, the corresponding diode is in reverse bias condition, and those inputs are 0, the corresponding diode is in forward bias, and the collector base junction diode is in reverse bias. So finally, the transistor Q1 is operated in active region. Therefore, the Q1 transistor output is given to input of this Q2 transistor, and the output of the Q1 transistor is logic 0. Therefore, the sufficient voltage is not given to the base terminal of this Q2 transistor, and this Q2 transistor is operating in the cutoff region. Therefore, we got the input of this Q2 transistor is logic 1 and the input of this Q4 transistor is logic 0. So when we apply the logic 1 is input of this base terminal of the Q2 transistor, and this Q2 transistor is operating in saturation region. Okay, so here exists a conducting path from the VCC to output terminal, and we got the output equal to logic 1. At that time, this Q4 transistor input is logic 0, therefore the sufficient voltage is not given to the input of this Q4 transistor, and this Q4 transistor is operated in cutoff region. Clear? And for example, here we are considered the A input is 0 and B input is 1. Okay, and we got the output is logic 1. Okay, and the next possible combination of input is both the inputs are high. That is, when all the inputs are in logic 1 state, the emitter junctions of Q1 are reverse biased and the current supplied by the source is sufficient to operate Q2 and Q4 in saturation and the transistor Q3 is in cutoff region. Therefore, we got the output is in logic 0 state. It means that in this circuit we are getting the both the inputs are 1 1. Okay, so these two emitter base junction diodes are operated in the reverse bias condition and the collector base junction diode is operated in the forward bias condition. Therefore, from the VCC we got the output of this Q1 transistor is in logic 1. Okay, that output is given to input of this Q2 transistor. Therefore, the sufficient voltage is given to the input of this Q2 transistor and this Q2 transistor is operated in saturation region. Okay, so at that time, the input of this Q2 transistor is logic 0 and the input of this Q4 transistor is logic 1. So when we apply the logic 0 is input of this Q2 transistor, the sufficient voltage is not given to the base terminal of this Q2 transistor and the Q2 transistor is operated in the cutoff region and this transistor is acting as open switch. Okay, and with respect to this logic 1 input, that is, the sufficient voltage is given to the input of this Q4 transistor and the Q4 transistor is operated in saturation region and the Q4 transistor is acting as closed switch. Okay, so at that time in this circuit there exists a conducting path from the output to the ground. Okay, so finally we got the output equal to logic 0. Okay, so in this way we are designing the TTL NAND gate with a totem pole output structure. Okay, thank you.